Hello everyone, so today we are going to learn about titration. So titration, initially it is used to measure the purity of gold and silver. It is used to find how pure the gold and silver was. But in chemistry you are going to see titration in a different form. That is, you are going to understand it like, okay, so for example, I have a substance A and I have a substance B. In chemistry, what you are going to do is that you are making this solution A, and you don't know about B. Okay, what you know about A is that you are making A, so you know the volume, you know the mass you have taken, you know its strength. Okay, but for B you only know about the volume and you need to find out the strength. So to perform this thing we are going to see the titration process. Okay, titration process is very simple. What you are going to see is that with the help of A, you are going to find out the substance B, the strength of B. What you are going to see is that you are reacting these two, A and B, and you will found a midpoint. Okay, a midpoint will come, and how you know that midpoint? When A is equal to B is when you use an indicator. Okay, this indicator is nothing, it's the point, it shows the point where A is equal to B. Okay, and in chemistry you are going to understand all of this. Okay, so your first experiment in the titration is to make the standard solution of something. Okay, so the standard solution you are making is to understand, to know about its strength, volume, mass and everything, so that with the help of A you are going to find the B. So the first thing that you will perform is to find to make the standard solution. You'll make the standard solution, you'll take indicators. The common indicators we see is phenolphthalein and methyl orange. And phenolphthalein, when it reacts, it forms phenolphthalein ion, which is pink in color. Earlier it was colorless, then it becomes pink. If the solution becomes pink, slight light pink, then you understand that okay, A is equal to B now. For methyl orange, initially your solution is yellow, but suddenly a streak of red is coming into it and your solution is becoming very light red. That will show us okay, A is equal to B. So for that, to find out the values, to find out everything, we are going to perform titration. So for titration, obviously you are going to have solution A and solution B. A, you have to make it so you know everything about A, molarity and everything. For B, you know about the volume. How you know about the volume is that, let's just see what you are going to do is in your copy. In your copy you have to write your aim, material, observation, and you have to make the observation table, precautions and the results. Okay, and calculation. So first of all, what you are going to see is the apparatus. Okay, in titration a lot of apparatus are used, so don't be confused in this. The longer tube like structure is the burette. This is the burette, and a small tube is the pipette. What you're gonna do is that solution B that you will be given in a beaker, you are going to pipette out. Okay, pipette is this type of a thing, very big. I'm making a very big pipette. You are sucking solution from your mouth and creating a vacuum, placing the thumb over there after sucking it, and then measuring it, okay, how much we have used, and pour it in the conical flask. Okay, and the standard solution that you have make, you need to add in this burette. Okay, and you don't need to add directly, you will get a funnel like structure. Okay, my drawing is pathetic. This is a funnel like structure. From there you are going to pour your standard solution. Okay, now you'll see a stopper in the burette, and what you are going to do is that slightly open it so that drop by drop your standard solution are going down. So what happened here, it is your standard solution, and we are using what, oxalic acid, and in this there is NaOH plus your indicator. We have used in this is phenolphthalein. Okay, we have used in this, so this is a solution of NaOH and phenolphthalein. What you are gonna do is, drop by drop it is going down, and when it reach a very light pink, and you're going to shake this. Okay, shake this so that it will be not concentrated on one point. You will shake this, that means you're mixing it, and it becomes very light pink color. If you are not going to stop, it will become a dark color, and that will not give you the exact value in the reaction. So you need to understand that whenever your light pink occurs, then you are going to note down the reading. Initial reading you have noted down, and final reading, and you need to make a chart. You need to write initial reading, final reading, and then minus it, you'll get the volume of NaOH. Initial reading, final reading, then you're going to find your volume of NaOH. I have an example. Okay, so let's just understand thoroughly. Okay, so what happened is that first of all, equivalent mass you need to take out for both the cases, NaOH and for oxalic acid. It is the molecular mass upon 2 and molecular mass upon 1. Nothing more. Equivalent mass is equal to molecular mass upon the n factor. What is this n factor? For oxalic acid, 2H plus ion will be gone, so it is 2, and for NaOH, OH, single OH will be gone, that is 1. So molecular mass you know of every molecule, then you need to going to divide it from the n factor. Oxalic acid it is 2, and for NaOH that is 1. You will get the equivalent mass. Okay, then what you have performed your experiment, and you have found your values of initial and then final reading. So for burette that is 0, and then that will, whenever you'll stop, you write the reading, and then minus it, you'll get your value. Then that value will be the initial value. Then you need to pip it out. You need to take this beaker and rinse it in the sink, and prepare the another NaOH and phenolphthalein by taking the NaOH from the pipette and pouring it to the beaker. You need to perform this pipette 3 times, and you'll get the answer. Then you're going to throw the solution and make the fresh NaOH and perform it 2 or 3 times, and you'll get the average value. Here we have 10.1 as an initial value, as in volume of NaOH. So what I have told you about A and B. Okay, A, you have made this is the standard solution, so you know its strength, its volume, its mass. For B, you need to find its strength. For strength, you need to find its volume. So you have got the volume of NaOH. Now what you are going to see is that N1 V1 is equal to N2 V2. N1 and V1 is for NaOH, and 2 is for oxalic acid. Okay, and oxalic acid is 1/10. You know the normality because you have made the solution. oxalic acid, you know the volume of oxalic acid that you have taken, and you from the titration you got the volume of NaOH. Okay, now divide and multiply it and you'll get the strength normality of NaOH. Okay, whenever you have to find the strength is nothing, it is the normality into the equivalent weight of NaOH. So normality we have found, that is 0.099 N, and equivalent weight from the initial, like molecular mass upon the N factor, we got 40. So put 40 there and you'll get the strength, that is 3.96 gram per liter. Now your required aim has been completed and you got the strength of sodium hydroxide with the help of titration. So there are a lot of precautions that you need to make. You will make it, and this is all about titration. Hope you have understood it. Hope you will not confused with burette and pipette, or what we have to take in the beaker, or what we have to take in the burette, what we need to pour in this long tube. You're not going to confuse whenever your teacher will see it and give it. And I'll see you next time.